Assalamualaikum warahmatullahi wabarakatuh. So we are from group 1 and we are going to present our project for hydrology, and our title is Catchment Area in Negeri Sembilan. So this is my group members. So first, me myself, my name is Farah Wahida binti Uze, and next is Huvin Raja anak lelaki Logeswaran, Wan Muhammad Daniel bin Wan Saiful Haq, Muhammad Ashraf bin Muhammad Zaki, and the last one is Nur Aisyah binti Jusuf. So today I'll be presenting for our project on the hydrological assessment of flat prime rivers in Negeri Sembilan. So we focus on three key locations, which is Sungai Linggi at Kampung Mantau, Sungai Linggi at Kampung Linsom, and Sungai Pedas at Kampung Pilin. So we choose this location because of the frequent flooding, so especially during the monsoon season. So we use Google Earth Pro, and we map the catchment boundaries by identifying high points around the river to understand where rainwater collects and flows. So tools like topographic maps and hydrograph help us study the elevation and river discharge patterns over time. So the Linggi River, which flows from Pantai to Melaka, and its tributary, the Pedas River, are crucial for water supply, agriculture, and industry, but also vulnerable to seasonal floods. So places like Kampung Lisom flood almost every day, even though mitigation and monitoring efforts have been introduced. So since these rivers are interconnected, so integrated watershed management is essential and important to reduce flood risk and ensure sustainable water use for the safety and well-being of local communities.
Hi, my name is Wan Muhammad Daniel Wasifullah and my registration number is DF230021. Today I will talk about objective. There are three objectives in this project, which are: 1. To analyze rainfall and water level, data for the selected catchment area and associate river. Second, to determine upload the unit hydrograph for the selected station and river. And the third, to calculate the peak flow using hydrological method and analyze impact on the catchment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Zaki. My matric card number is CF2030263. I want to explain about this slide methodology this project. For this study, we selected a catchment area located in Malaysia as our main focus. The first step involved visiting the Infobanje website managed by the Department of Irrigation and Drainage Malaysia. From this website, we collected hydrograph and hydrograph data for our chosen location. This data sets show the river flow patterns and rainfall distribution over time. We also use Google Pro to identify and delineate the catchment boundary, assess the topography, and locate nearby rivers or streams. Once the once the data was collected, we analyze the rainfall and runoff patterns to understand the peak flow and response of the catchment. Based on this analysis, we develop a hydrological model to simulate water movement and flood behavior in the area. The entire process allows us to evaluate flood risk and improve water resource management strategies for the selected catchment. Thank you. Assalamualaikum warahmatullahi wabarakatuh. So this slide the show about website public info banjir system and Google Pro. The info banjir system collect real-time data from over 200 hydrological stations nationwide. The data is sent to the National Flood Forecasting and Warning Centre, known as PRABN, under the Department of Irrigation and Drainage, or DID. So you can look this picture about Public Info Banjir and Google Pro. Assalamualaikum warahmatullahi wabarakatuh. So this slide show the the picture, the annual data hydrograph at the selected location, and second, uh, the data graph is color orange, show the annual data hydrograph at the selected location. So the data we can get from the public info Banjir. Thank you.
Okay, my name is Nur Aisyah binti Yusuf. My metric number DF230029. Now I will present the rainfall and water level data collected for the month of November 2024 at the three different stations. For the first station at Sungai Linggi in Kampung Mantau, the total recorded rainfall was 408 millimeters, which was the highest amount of the three stations. The most significant rainfall occurred on 24 November, which 61 millimeter recorded in a single day. There were also other moderate rain even around mid-November. This distribution is shown in the hydrograph in figure 3.11. Net at Sungai Linggi in Kampung Linsong, the total rainfall was only 34 millimeters, indicating very dry condition throughout the month. Most days recorded zero rainfall, except for a few small peaks on the 30 and 50 of November. This can be clearly seen in the figure 3.1.2. Okay, next, moving to Sungai Pedas in Kampung Pilin. The station recorded a total rainfall of 3,001 millimeter for the month. Every rainfall occurred on 10, 22, 29 November with daily total of 40, 33 and 45 millimeter respectively. The hectograph in figure 3.1.3 highlight this rainfall peak. Now regarding water level data at Sungai Pedas in Kampung Biling. The maximum water level recorded was 9.85 meter. The total sum of the daily maximum water level throughout November was 189.68 meter. However, it's important to note that some day has missing data, especially toward the end of the month. The hydrograph in figure 3.2 show the fluctuation in water level during the observation period.
So for analysis and result, for the first method is we use arithmetic mean method. So this is the easiest method. So for the method, first we need to find the total rainfall for each station, which is for Sungai Linggi at Kampung Mantau, we got 170. Sungai Linggi at Kampung Linsong is 7.5 and Sungai Pedas at Kampung Biling is 100 mm. So we total up the total rainfall for these three station, and we divide it into total station, which is 3, and we get the precipitation is 92.5 mm. So for the second method is we use Thiessen polygon method, where the catchment boundary we split into 3 different polygons by using Google Earth Pro. So we get the area for each station. So from the total rainfall is from the data, and we need to find the area multiplied by total precipitation, which is total rainfall. So we get the total for area, which is 21.14, and the total area multiplied by total rainfall, which is precipitation, is 1744.4, and we just insert to the formula given, which is the formula is polygon area for each station multiplied by precipitation and divided by the total polygon area, which is 1744.4 divided by 21.14. So we get the precipitation is 82.52 mm.
For the rainfall data, isohydral method. This figure demonstrates the application of the isohydral method to estimate the average rainfall across a defined catchment area. The catchment, shown in green on the map, is divided into several zones based on isohydral lines, which represent lines of equal precipitation. The area of each zone was determined using Google Earth Pro and then multiplied by the average precipitation value for that interval. As shown in the table, Each isohydrate interval contribute a different portion of rainfall depending on this area. By summing up the product of area and precipitation and dividing by the total catchment area of 15.46 kilonewton square, we obtained the weight average rainfall, which is calculated to be 51.80 millimeter. This method provides a more accurate representation of spatial rainfall distributed over the entire catchment.
Hi, my name is Surajan Leglexura, CF230102. So my part is about stream flow and water level data. So first, our flow is going to use by many equation. So widely used by empirical formula in operation hydraulics to estimate the flow rate, discharge of water through natural or man-made channel. And this project, the main equation was applied to determine the discharge of as Sungai Pedas at Kampung Pilin, Rembau. Based on field measurement of the river cross-sectional area, wetted perimeter and slope and channel slope. So from this equation, we're going to use for discharge method. Q equals to 1 over NAR 2 over 3 SO 1 over 2. Okay, so from this data that we given is for 15 days of our day for data, and we did our calculation for water level, for flow rate, base flow, direct flow, and UH ordinate. So from the direct flow we got 0.88. That's the value for the stream flow.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Mauzati. My metric card number CF230263. So this slide, I want to explain peak flow is the maximum discharge that occurs during a storm or heavy rainfall event. It represents the highest amount of water flowing at one time through a drainage system. Peak flow depends on several factors, uh, like land over, cover like building, roots, and grass. So soil type, topography or land slope, and rainfall intensity. So the understanding peak flow is important because it helps us to firstly design effective drainage system, second prevent flooding, and third and protect property and the environment, and four, on the right side, we have a map of Sungai Pedas Kampung Piling, which is our study area. We use Google Earth Pro to trace the catchment boundary. So below the map, you can see the elevation profile of the overland surface. This show how the land slope from upstream to downstream. From the data, the sheet flow path length is L equal 1.15 kilometer, which equal um which equal 1,500 meter. The slope of the surface is S equal 5.1 percentage. This value will be used later in further calculation to estimate the peak flow. So that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muzaki. My metric number CF230263. So for our hydrological of study, we selected Sungai Pini in Rembau, Negeri Sembilan as our case study location. To estimate the peak flow, we apply the rational method, which is commonly used approach in urban hydrology. This method requires the calculation of the time of the concentration, denoted as TC. In our project, we assume TC equal TO. TO is meaning time of overland flow. We use the following formula to calculate TO. So you can look 107 um, darab 0.035, and another step, we get TO equal 30.09 95 minutes and TO 0.52 hour jam. Hmm. So this value were then used to determine the rainfall intensity I from the MASMA table based on specific return period. Additionally, we refer to table 2.2 from the QUDM 2007 guideline to determine heterogeneous coefficient N, which is important for the understanding surface resistance and flow behavior. For example, paved surface have an N of 0.015. So the sandy grass area have an N of 0.060. Parameters such as lambda, kappa, and theta and eta were also taken from MASMA table to point B1 to support our calculation. From your information, uh, lambda is meaning runoff coefficient adjustment factor. So kappa is meaning rainfall intensity factor or empirical constant. So theta meaning time adjustment factor and eta exponent in rainfall intensity formula. So thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf. I go through the next slide about peak flow rational method. For this part of the study, we focus on calculating peak flow using the rational method with Sungai Pinit in Rembau, Negeri Sembilan as our study location. To estimate the peak discharge, we first needed to determine average rainfall intensity I based on the IDF intensity duration frequency relationship. We refer to table 2.B1 from the MASMA which provide the constants lambda, k, theta and eta for various stations across Malaysia. Since our study site in Negeri Sembilan, we selected the nearest station iaitu station 3 Sungai Kempis and use the corresponding value. So lambda we get 54.400 and K we got 0.176 and theta 0.134 and eta we got 0.842. Using the IDF empirical equation uh, where where I where T is the return period, we use 100 years. D is the storm duration, equal to time conservation, 0.52 hour from earlier, and I is the average rainfall intensity in meter per hour. So substitute the values into the formula. You can load the the calculation. So this rainfall intensity value will be used in the rational method formula to calculate the peak discharge for our selected catchment area. So we got 172.95 meter per hour. Thank you. Hai, Assalamualaikum warahmatullahi wabarakatuh. For this slide, I will explain about peak flow calculation in hydrology. First, let's look at the table on the left, which show the runoff coefficient C. These values are taken from MASMA to and the addition table 2.5. The runoff coefficient represent how much of the rainfall will become surface runoff depending on the land use. For this slide, a bungalow area has a runoff coefficient of 0.40 for a minor system 5-year RE and 0.70 a major system 10-year RE. Industrial areas have high value up to 0.95 because the surface are mostly hard and do not absorb water. So let's talk about the formula in the right side. With the we use the formula to calculate peak flow. Q equal C times I times A and divided 360. So C is the runoff coefficient. I is the average rainfall intensity in millimeter per hour. So A is the catchment area, and 316 is a constant used to convert unit into meter cube 3 per saat. So Q equal, you can look 0.40 times, we got 172.64 and time 21 for 21.14 and divided 316. So we calculate, we got the peak flow Q equal 406.22 cubic meter per second. So that's all from me. Thank you.
The cross-section profile of Sungai Pedang at Kapupilin was obtained using Google Earth. The reverse section has a slope of 0.1% and a mean roughness coefficient N of 0.035. Based on the profile, the calculated cross-sectional area is 360.2 meter square, with the weather perimeter is 104.92 meter, resulting in a hydraulic radius of 3.43 meters. Applying many formula with this value, the estimate peak discharge for this section is about 740.18 meter cube per second. This calculation help us understand the river flow capacity during high flow or flood event.
So for discussion rainfall data, for the study area rainfall data was collected from 3 nearby rain gauge and 1 water level station provided by the Department of Irrigation and Drainage. The map was calculated using 3 methods. That's for example, the first one is arithmetic mean method, second one is polygon method, and the third one isolator method. So since we calculate all the answers, should be getting 92.5 for arithmetic. For Tism method, we got 82.52. The isometric method for you get 51.8. So the rainfall data distribution is influenced by factors such as prevailing wind, topography, ocean temperature, and seasonal changes. And warm ocean water increase evaporation, adding moisture to the atmosphere and intensify rainfall when it is moist air reaches land. So for the stream flow, refer to volumetric discharge expressed in volume per unit time occurring in a stream or channel which varies over time and space. Water level is the height of the water surface, such as sea level or a standard elevation for measuring land elevation or sea depth. In this project, many equation is employed to calculate the discharge and the hydrograph is generated. Hydrograph included fundamental components such as direct surface runoff, interflow, base flow, and channel precipitation. It also features key elements like the rising line, crest, recession limb, time to peak, time of some concentration, lag time, and time base, as detailed in section 4.2 on streamflow water level data analysis and result. So for the discussion, peak flow is a maximum discharge of water in a river and is a key factor in flood risk assessment and hydraulic structure design, as it more accurately reflects potential flood event than average flow. So for several factors influence peak flow is geologically. For example, pre-immersible rock absorb more water, reducing surface runoff and peak flow. Impermeable rock lead to faster runoff and higher peak flow. And the second one is drainage basin characteristic. Larger basins collect more water, leading to higher peak flow. Circular basins concentrate flow more quickly than elongated one. Increased peak flow, steeper slope also accelerated runoff, raising peak flow compared to flatter basin.
For the conclusion, the study revealed important pattern in rainfall and river level change at Sungai Pedas, Kampung Pilin. Seasonal monsoon and local storm cause notable water level recedes, especially in low-lying area prone to flooding. By using Google Earth Pro and elevation data, period on significant river risks were identified, confirming the link between rainfall and hydrological response. This finding highlight the important and continuous monitoring, real-time data, and flood risk mapping. The results support better planning for the flood management, infrastructure design, and long-term water resource sustainability.